and welcome to yet another video on Over the Wires wargame Natas. Today we're on level 27 and I got some exciting stuff for you today. I will show you a methodology on how we can find obscure and funny vulnerabilities, even the ones that we don't necessarily know to test for, we should be able to discover. So my name is Chris Stale and I've been doing penetration testing for a while now, and these YouTube videos is a good way for me to disconnect from my daily work a little bit and share back to the community. So what we have here, we have this username and password login form, and we want to get to the next level, level 28. So how do we go about that? Well, first thing is, why don't we try logging in with admin. As you can see, it says admin user was created. Pretty cool, pretty cool. Let's try log in with admin. And it says, welcome admin, here is your data. And you can see that we simply get a little array dump, like a print R or like a var dump back to us. Okay. So let's try with things like double quotes. Double quote was created, logging in with double quotes. Did not work in any particular way. Let's log in with a tick. User tick was created. And you see that we need to provide a correct password. That's a good thing. And we do seem to have proper sanitization here. What about Natas27, which is the next level? Wrong password. All right, cool. So let's fuzz, okay? And the process of fuzzing here is important, and it is very useful to have a way of fuzzing in a predictable manner that will allow you to find the most vulnerabilities. So I'm going to log on first and capture the request in burp. I'm going to press Control I to send this request to the intruder so that I can configure parameters here, okay? Now I'm going to be here adding a parameter, and I'm going to be adding a parameter here, and I'm going to launch, let's see, well, let's do the battering ram attack, which basically takes one payload and puts that one payload into both of the positions here. While the sniper will go through one payload, one at a time across all the positions. Pitchfork will take multiple payloads and just basically ram them in at the same time. And cluster bomb is like a double for loop, going through one payload for every other payload that you define. Battering ram, in this case, might be a okay approach. Then what we're going to do is we're going to use numbers. We're going to go through numbers from 00 to FF, so that's hex. And we're basically going to have two numbers always. So notice that this makes 256 characters, which is correct. So I want to fuzz, and I want to show you how to fuzz for all possible bytes available to this application. So I'm going to do add here, and I'm going to add a little prefix, which is going to be the %. So in front of every byte, I'm going to add a percentage sign, and that causes us to now have URL encoding. And since we are inside of a post parameter here, we don't really need URL encoding. So I'm going to basically say, hey, URL decode. And these payloads are processed in order. So we start by adding the prefix, then we decode. So let's see what happens now when we click start attack. You can see here we have a response. It says user was created. So I'm going to actually, for our next attack here, I'm going to add what we call a grep extract, so that in my output of the intruder, the fuzzing tool here, I will always grab the value of the div contents. So the contents inside here, I always want to grab. In fact, why don't we do like this? So that way I will have a way to quickly look through the contents. So sorting through the contents here, you can see that a bunch of users was created, and I'm going to ignore these and I'm going to look at the ones that changed down here. This user was created. Okay. So user was created, and down here we have a gap in the content length as well. So I'm just investigating, why do we have this gap? And the gap is because the greater than or less than symbol here was replaced with its respective HTML entities. That's fine. So we expect to see gaps here. What about this character here? Why does this one create a larger reply? And it's 11 bytes bigger than the one before. Why is that? So I'm going to take these two requests, and because we have this discrepancy, I need to investigate. If I have senior pen testers on my team right now, I would maybe call them in so that we could consider this problem together. But let's compare these two responses here. Send the responses to the computer, and let's figure out, why do we have difference. Welcome, here's your data, and in this case, user was created. So there we see that we have 11 more bytes of content because it says welcome, here is your data. Okay, so that probably means that all of these one here also says welcome, here's your data. And that's the nice thing about the grep extract. I'm gonna add it real quick here. It will quickly show us what content we're looking for. So allows us to assess the situation quicker. So we're just scrolling through. Very interesting that we are not seeing any characters here. That might be something. Okay. So I'm just looking for any error, any type of potentially missing filter. You can see the HTML replacement here, the HTML entities, the ampersand is being replaced with amp here, GT, LT, and so on. And a bunch of users was created. And also here, this is kind of interesting because apparently this character, this one here, this Natas, I believe it is, or this, or for example, these characters here already had a user on the system. And that might be because we are doing some sort of translation or normalizations of the characters. So for example, this character here, maybe this one here is just simply an A in the back end. So could potentially allow us, for example, if we have something that looks like N here, for example, maybe that could allow us to log on with Natas28 potentially. Here, for example, N already have an account, and that's probably because we fuzzed an uppercase N here. Yes, user was created. I want to test this theory, so I want to see if I can do test, all uppercase, log on with the password test, lowercase. Test was created. Now let's try lowercase test with the same password test, and you can see we could log on. So that's kind of interesting now. The username is uppercase in the database, but I supply a lowercase username, kind of gives us an idea of how the backend here is comparing the data. It's comparing case insensitive, and that's important for you to basically note behind your ear, maybe put in like your working document saying that, hey, we are doing case insensitive comparison. So maybe I could now potentially create a Natas28 user with a password Natas, for example, and it says wrong password. So you can see that we're allowed to create users with different casing, and but the log on is basically removing the case and doing a proper check there. So not some upper lowercase trickery, that will not work here. So kind of interesting that these characters are replaced. I'm thinking about these here. So for example, this, let's go to, for example, here, for example, the user was created. So let's try log on with and the password user was created. One more time, and we logged on. Let's try with an O now, and the password and that did not work. So it did not just like normalize the into an O, for example. That there's something else happening there. These are answers that in a pen test I would probably want to have answered. So let's continue with our fuzzing activities. So let's go into the intruder here, positions here, and maybe we want to say, for example, we know we have a target. Maybe we have an admin user, the Natas user here. We have a target. Why don't we see if we can maybe add some special characters to this user? Maybe there's an error in the parsing. Maybe there's something that we can go off within this parameter itself here. Same thing with password, but we have already fuzzed the password with the battering ram attack. So I don't think we will have anything to go off with the password. So let's now add at the backside of Natas28, let's see if there's anything we can maybe produce to cause it to leak information, or in some case allow us to figure out what's wrong or where the bug is, the vulnerability. Wrong password for using Natas28, that is fine for the first payload because we just tried it without any type of extra payload whatsoever. And then we're trying with a null byte, we're trying with all kinds of special characters here, logging in, and you can see that we're actually creating users here, okay? So we're creating users with these special characters. For example, here's a tab. I'm gonna try to send this to the repeater and log on. And you can see, welcome Natas28 tab, and you see the tab is represented in here as well. That's pretty cool. So tabs are allowed to put in. You can create users with all of these special characters and basically represent or look alike like Natas. Can you imagine if this was a real system? Like I might now impersonate the Natas28 user in a social engineering attack. So that would be a bit scary, to be honest. So consider that. Wrong password for Natas28 when given. Ooh. Now this is super exciting. Spaces here are seemingly removed or truncated. So that's interesting. So I'm gonna hold on this one. And then these ones are already, they have an account. So basically we have output, okay? And user was created for these special characters as well. I want to run all of these again, just because one request creates the account, while the second request logs the account in, and I want to check to see if there's any differences. And the one with the space, I'm gonna put a little. I'm gonna keep that one behind as in my memory. Like space seems to impact the input, right? Because I could see that when given a space %20 here, something funky happened. I was allowed to basically I'll add a space and still try to log on with the new Natas28. That's a bit interesting. Okay, so let's go with the fuzzing here and just check to see what changed when we ran the requests again here. So now you can see we're logging in with a bunch of accounts because now these accounts have been created, and I'm just looking through the output here, the arrays here. Maybe we have some JSON injection, maybe we have some way to manipulate something. So I'm looking for discrepancies, I'm looking for anomalies, I'm looking for anything that might give me the idea that, hey, here is a vulnerability. Here we have some ... what is this? And it's just basically truncation there. That's fine. So I'm going to full screen this one to give us more room. And I'm just going through all the data here. Oh, and this one here. You see how this one stands out? When given this %20, I'm going to fuzz on the %20. I'm going to use that one now. I'm going to save this %20 byte as my next step in my fuzzing. So keep that one with you, okay? So let's see. Here's your data. I don't see any discrepancies in length. Here we see some discrepancies. Here's your data, welcome, nothing. Here's your data, nothing. This is exciting stuff. So all of these here, all of these bytes higher than 129, we want to investigate and we want to figure out what might be wrong with them. That's what I would do in a real pen test. So why do these have this significant meaning? If you open up ASCII-table.com, for example, you might see that they are actually outside of normal ASCII scope. And that could maybe you could find vulnerabilities on a database level or otherwise encoding errors potentially and so on. So here we see welcome, and we don't see any funny stuff. I love these ones here. When we have an empty result here, here is your data. That to me as a pen tester, I'm curious, and that's exciting. Like, why is there no data being pulled here? We might use that for some kind of exploit, pair it up with like another character, and we might find some data. All right, so far so good. So far so good. I'm gonna continue now my fuzz. I'm gonna add basically here, I'm gonna have two variables. I'm gonna do a cluster bomb attack. The first variable is going to be of a simple list, and it will contain all the bytes that I found that was special. So from the previous list, I copy out all the special bytes that I felt had a significant meaning to the application. For example, space, all right? So I add a space to this list. Now, payload number 2, so for every space and any other bytes I wanted to add, I'm going to do basically the same thing I did before. I'm going to add from 00 to FF, step 1, hex 2, and add prefix, here, percentage, and then we're going to add decode URL. I also don't want to URL encode any spaces because we are inside of the post here, so I want to leave those off. Something is wrong here. URL decode. So let's see. Add prefix 0. So %00. Let's go with this one. So %00, and this turns into. Okay, so I have a little bug here. So I need to fix my fuzzer here real quick. Here we go. So this is payload 1, this is payload 2. So payload number 1, it was URL encoded. And we're going to remove those. Just a bug in my payloads here. So there we go. Now let's try again. All right. Default request here. You can see wrong password for the user. That's fine. And this is exciting. Ooh. Look at this. This is what we can play off now. Okay, so we can see we add a space and then new bytes, and all of a sudden we are creating more users. So that's interesting. And then we have wrong password when given an extra space again. Okay. So spaces are truncated. Now that begs the question: what happens when we fill up the entire table to the point where it's full, like the column, sorry, when a column cannot hold any more characters? How does PHP and a database handle that type of data? Because you know there might be vulnerabilities in MySQL in terms of how it processes data. So I'm seeing all these users created, but the output are not giving us anything exciting yet. Let's request item again here. One more time. So I'm gonna basically do all of them. First of all, I want to check the length. No interesting length. So request items again, because this will allow him to log on now if these has been created. So let's see what happens now. We log in one more time. Here's your data. I'm looking for any discrepancies in length. For example, this one is longer than the rest. Why? Because it has a quote here. And yeah, so far so good. I mean, we have some exciting stuff with the spaces. So why don't we test the spaces? What happens if we give it so many spaces that it fills up the table? And this is really interesting stuff in this challenge. So let's go here. And in payload number 1, we notice that we can give it a bunch of spaces, and we can create also user accounts containing spaces that will basically look like Natas28, but it won't be the real account. So what happens, for example, here? Instead of adding the space, now let's continue with the space. Let's add a bunch of spaces. So we're going to do brute forcer here. We're going to do space, min length 1, max length 100, for example. No. Let's do character blocks. Base string space, min length 1, max 100, step 1. So that will be, okay, I see what we're doing here. Yeah. Right. We don't need a cluster bomb anymore. We'll do sniper attack. And instead of 2 payloads here, just add test. So let's see what happens when we add a bunch of spaces. And I want to see what happens when we fill up the back end column with so many characters that it can't hold anymore. So say, for example, you have a database describing a username. That might be maximum 20 characters, for example. It might be maximum 100. It might even be more. But let's just see what happens here. So you see that we're creating users. That's great. And you can see the spaces being added. And, yep. Look at this beautiful pattern here. Look at this. You see, it grows, all up to the point where it cuts off. Created. This is just because my output here. Okay, so it's just might be just my output being truncated here. But kind of interesting. I was hoping that we would see a maximum length here of a user. And why down here we don't get any input? Okay, so that's because of the truncation of burp suite. Okay, so that's disappointing. Now we request these items again and try to log on with them. Here's your data, beautiful. So we can now log in with these users with the spaces. So what I'm going to do is in our grep extract here, I'm going to basically do this and add a fixed delimiter 200. Okay, so I want to grab more data here. Still didn't work. Okay, so I'm looking down here. Here's the data. And it's being added. Oh, there's a change from here. So this is where we log on with our data. Greetings, welcome, Natas28, and 53 spaces, and then test. It worked. Look at what happens now. 54, user was created. So let's log on then. Cannot log on. It was just created over and over. And this must have something to do with the database truncating our data. So we can seemingly create it, but we can't log on with it. So there's something funky going on here. In fact, if we take now the username here, for example, with or without the spaces, go back here, add, use a login name of, was it capital A, lowercase a, so lowercase a here, log in, we got the flag to the next level. And some of you might, and myself, the first time I did it, were like, what is this? What is going on here? How does this work? And to figure out how it works, we have to take a look at the source code, okay? So looking at the source code, we are seeing that there's a varchar 64 here, okay? And that describes the function here, 54. So let's do some simple math, okay? So let's do 54 plus Natas28. Natas28 is 1, 2, 3, 4, 5, 6, 7. So 54 plus 7 is basically 61, right? 61. And we have maximum 64. So here we have TEST. So I'm guessing that this fills up to the point. Actually, I'm a bit curious here. Why does this not equal to 64? I would expect this to be 64 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 50. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's so strange. I would expect this to be 64 precisely. Let's go open up CyberChef and make CyberChef count for us. I'm just going to explore a tiny bit more before I move on, because I'm very curious myself here. And that's how we learn, right? That's how we learn, basically, by being curious. So just drag and drop CyberChef into Firefox here. And I want to make sure that my counting here is not off. Yes, 61. So there's 3 more characters until this table fills up. So that means there's something going on maybe in the background here then. Well, maybe there's something going on further down here that we haven't looked at yet. Okay, that's fine. Then we basically have check credentials, select username from users where username equals, and but MySQL is case insensitive here, so that's fine. And if MySQL number rows more than 0, we're going to return true. That's fine. So the credentials were okay. Okay, this is cool. Valid user, select star from users where username equals, so case insensitive search here again. And also, funny thing is, with the varchar 64, we're basically building out the entire string to the point where it's, well, we're creating a user and checking the credentials here, but the credentials are, sorry, the varchar here is automatically truncating the spaces, so it looks like we're actually logging in with Natas28 instead of the capital A's. Pretty interesting stuff. Let me show you how this looks like in a database, okay? So I'm going to go here, and I'm going to run this query here. I'm going to run this query here so that we create a new database, and now we're going to insert into users. So we're going to insert in the username and the password columns. We're going to insert the following values. We're going to insert Natas28 and a password we don't know, okay? So far, that will allow us to basically inject one user into our own database so we can experiment. So now we have Natas28, we don't know this password. Now we create a new user. We create a new user that we control, but this user has a, basically what we're injecting is, let's go back here, we're injecting this into the table, right? So I'm going to do this, and we know this password, it's just A. Now select star, or actually data truncated warning, so we got a warning, that's fine, truncated data. Select star from users, okay? So this is how we look at the data. So select, so basically we put this in. Let me add one more space, inject, notice that TE disappears. One more space. And one more space. Now we basically have a user down here that looks like Natas28, but we know the password, okay? That's awesome. So when they do check credentials in the source code, we're doing, the data is being truncated. So select username from users where username equals users. So let's do this. Select star from users where username equals Natas28. Returns 2 friggin' rows. This is MySQL being very friendly with you. It truncates the spaces, and if you don't know this is happening, this is why we have vulnerability. So if you don't know this is happening, you will have vulnerabilities like these. Pretty cool stuff. Whew. Well, I hope you like this video. I hope you like this type of exploit. To me, first time I saw this, I was baffled. I was like, wow, MySQL and databases can have so many interesting things in them. But the key lesson here is to fuzz. You will not be able to know in advance of all the vulnerabilities you're looking for. There might be unknown, new classes of vulnerabilities that are never been heard of. So you need to go about fuzzing in this type of way, going stepping stone by stepping stone, going through all of the bytes, but also not forgetting to run a proper fuzzing, like fuzzing for known attacks on the side as well. So in the future, I will create a video on what I call minimum viable pen testing to show you how to go through the full methodology of covering the minimum viable pen test of a web app, and hopefully that will be interesting. So if you like this video, show some love, give me a thumbs up, maybe subscribe if you want to see more of my videos in the future. You guys are awesome. Leave a comment and have a good day. All right, peace out.